Hello and welcome to the next video on roots. Now in the previous video we talked about how we use two straight line graphs, and then when we multiply them together we got a resulting quadratic graph. Now the most important discovery is that the roots of the two linear graphs are exactly the same as the resulting quadratic graph. Okay, but in that video I kind of went through the multiplication of the two graphs rather quickly, so today I want to go through that in detail. So let's get started. Now, over here, I have two straight line graphs, y equals to x minus 1, y equals to x minus 2, which are the exact example from the last video. So now I'm going to talk about how can we multiply two straight line graphs together. Okay, what's important is that we're going to look at each and every y coordinate, right, of the red and the blue graph. And how I'm going to do that is I'm going to actually use a straight line here just to help you for a start to take a look here. So let's look at the y coordinates of the red and the blue graph as we move through x minus 1, x equals to minus 1, x equals to 0, 1, 2, 3, 4, so on and so forth. Okay, so as you can see, my dotted line is on x equals to negative 1 now. And if you look at that line, you will see that, okay, the red graph will have a y coordinate of negative 2. The blue graph will have a y coordinate of negative 3. So negative 2 times negative 3 is going to give us positive 6. So this is the resultant, our multiplication, which means my quadratic graph will go through x equals to negative 1, y equals to 6. Yeah, the coordinate of this point is this. Okay, now let's look at, say, when x equals to 0. Say if I move this here, right? What are the points, the y coordinates of the red and the blue graph? As you can see, for the red graph is negative 1, for the blue graph is negative 2. Now if I take negative 1 times negative 2, that will give me a positive 2. So that is the resultant, that is where my quadratic graph will go through. It will go through this point, x equals to 0, y equals to 2. Moving on to when x equals to 1. Now this is really important because this is going to be 0. It doesn't really matter what this is. So my resultant point will be 0. 0 times anything is 0. So my quadratic graph will go through this point. Likewise for the next point, right? This was the discovery that we had. Remember that the roots of the straight line graph is exactly the same as the quadratic graph. Okay, now I'm going to move on to the next point, x equals to 3. Now when x equals to 3, our red graph is at y equals to 2, our blue graph is at y equals to 1. So 2 times 1 is going to give me 2. So my quadratic graph will go through this point. Okay, and then moving right along to this, x equals to 4. Our red graph will be at 3. Our blue graph will be at 2. 3 times 2 is 6. And I'm going to stop here. I'm not going to go on to x equals to 5. And you can probably tell why, because when I move to x equals to 5, the red graph will be at 4. The blue graph will be at 3. 4 times 3 is 12. It's way beyond my axis. Okay, so I'm going to go ahead and sketch out the graph. I'm not very good at sketching the graph on iPad, so I hope you get the idea, the shape of the graph. Yeah, it's probably a minimum point in the middle of 1 and 2, and then try my best to draw a smooth graph. Okay, so it looks something like this. Okay, and yeah, instead of showing you a lousy graph, maybe I'll just show you what it actually looks like. It should look like this. Yeah. You should go through exactly the same points we plotted just now, and that is y equals to f of x times g of x. In other words, I can also say this is the graph of y equals to x minus 1 times x minus 2, and if I expand it out, that will be x squared minus 3x plus 2. Okay, so that's how we can multiply two straight line graphs together to get a quadratic graph. Now let's try one more example. A simple one again. If we look at question 2. Now in question 2, we have two graphs. Now it's going to be x plus 1 and x minus 1. Yeah, the green graph is x plus 1. The orange graph is x minus 1. So let's look at each and every y coordinates of the same x when we're looking at the same x coordinates, and then we multiply the y coordinates together. So starting from the leftmost, when x equals to negative 3, our green graph is going to be negative 2. Yeah, negative 2. Our orange graph is going to be negative 4. So negative 2 times negative 4 is going to give me positive 8. That means my graph will pass through this point. My quadratic graph will pass through -3, +8. Yeah, coordinates. Now let's look at when x is equals to -2, what happens? So I have a -1 over here. Yeah, -1. And then -3 over here. -1 times -3 is a +3. So it should go through this point. Okay, I'm going to move much faster now. This is 0. So it doesn't really matter what the y coordinate of the orange graph is. Yeah. The next one, we have 1 times -1. That will be -1. Okay, and the next one is 0 because the orange graph has its roots there. And the next one, we have 3 times 2. That is going to be 3 times 1. Not 3 times 2. 3 times 1, that is 3. And then I think the next one's the last one. We have 4 times 2, that's 8. Okay, and that is already at the edge of my axis. Okay, so instead of sketching it out and giving you a really bad sketch, here's the answer. Right, if you sketch it out, it should look like this. Yeah, and we can say that this resulting quadratic graph is the graph of u of x times v of x. Or I can write down the two linear expressions multiplied together, x plus 1 times x minus 1. And if you expand it out, you should see this is x squared minus 1. Yes? Pretty easy, right? How we can multiply two graphs together. Now, in the same way, we can do the reverse. If I given you a quadratic graph, right, you should be able to sketch out the two linear graphs that make up this quadratic graph. And the process is rather simple. You just need to look at this quadratic expression and factorize it. So y equals to x squared minus 5x plus 6. You can easily factor this into x minus 2, x minus 3. Okay, which means the graph that I want to draw is y equals to x minus 2, and the other straight line graph will be y equals to x minus 3. So very quickly, let me just mark out the points for x minus 2. Let's use blue, I think. No, let's use red. Okay, so x minus 2 is going to be, we'll have a y-intercept of -2. And then since the gradient is 1, it just goes up like that. This will be y equals to x minus 2. And then for x minus 3, it'd be like this. Right, this will be all the points. Okay, and again, I've prepared the solution. So you can take a look over here. This is what it looks like. Y equals to x minus 2, y equals to x minus 3. Okay, two straight lines drawn. And you can see that the roots of the straight line coincides with the roots of the quadratic graph. And we know why, because it's a multiplication. Yeah. Okay, now we're going to look at question number 4, which I feel is a very interesting question. Yeah, it's a thought-provoking question. Okay, so now let's say we have a quadratic graph that looks like this. Y equals to x squared plus 3. Would you be able to sketch out the two linear graphs that make up this quadratic graph? And that is quite interesting because you realize, hey, this quadratic graph doesn't cut the x-axis. Yeah. So how are we going to draw the two straight lines? And the answer is you can't, right? You can't. And then you might think that, oh, okay, yeah, we can't because there are no roots. Huh? Okay, you ask yourself the question. Look, the quadratic graph doesn't cut the x-axis. It does not have roots. But if you've been to, your A Maths class, you'll hear your teacher say this. This graph, right, has no, instead of saying no roots, there's one more word that your teacher will say, right? Your teacher will say that there's no real roots. There's no real roots, okay? And you might also recall that in the last video, I talked about this really famous and prolific mathematician, Gauss. And Gauss has proof that if you are a degree 2 quadratic polynomial, quadratic expression, you would have two roots. Okay, you would have two roots, no doubt about it. So then where are the roots? Okay, it turns out they are hidden. They are hidden, okay? And I'm just going to give you a short preview of why there are actually roots, why they are hidden. So very quickly, let me just show you something. Okay, let's say if we go back to question 1. Let's go back to question 1, okay? If you notice, our resulting quadratic graph has this equation, y equals to x squared minus 3x plus 2. Now, I'm going to try and look for some pattern. Okay, I'm going to start with the roots. First, I'm going to write down the roots. The roots are x equals to 1, x equals to 2. 1 and 2. And what if I add the roots together? Okay, I'm going to get 3. Yeah, I'm going to get 3. If I multiply the roots together, I'm going to get 2, which is quite a coincidence because there is a 3 here, although we have to multiply with a negative 1, negative sign. And then the 2 is here. We have the 3 and the 2 here. Quite interesting, right? Let's look at question 2 and see if there's the same pattern going on. Question number 2. Okay, question number 2 was x squared minus 1, but I rewritten it so that you can see it's x squared plus 0x minus 1. Okay, so now let's write down the roots. It's negative 1 and 1. The roots are negative 1 and 1. If I added them together, I'll actually get 0. And if I multiply them together, I'll get negative 1, which is exactly here. 0 and negative 1. Okay, and if you're still not convinced, let me show you with question 3. So question 3 over here, the roots are 2 and 3. If I add them together, that would be a 5. And if I multiply them together, I'll get a 6, which you can see over here. Negative 5, right? And a 6. Okay? Which means, if you look at the last question over here, x squared plus 3, the one that does not cut the x-axis, right? The one where there are no real roots. Okay? Although I may not know whether there are roots, but I know if you add the roots together, you're supposed to get 0, and you multiply the roots together, you're supposed to get 3. So that means there are actually roots, but we just don't know what this number is, what these two numbers are. Okay? So that is a glimpse into what we call complex roots, complex numbers, okay, which you will learn in junior college or polytechnic or in university. And I find that's really, really interesting. In fact, I might make a video about this, right? Maybe my next video will be on this, but it's not in the AMAT syllabus. So if you are not so interested in it, feel free to skip it. If not, yeah, I will continue to make more videos on quadratic equations. And I come to the end of this one because we're supposed to talk about roots anyway, and I think we found some really interesting things about roots. Thank you for watching. I hope to see you in the next video, and until then, catch you on the flip-flop.